Alright, this is an Edpuzzle lesson all about bias and unbiased estimators, which are actually pretty straightforward. That's why I saved it for an Edpuzzle. Alright, so you guys know that we have parameters and statistics. Parameters are coming from a population, right? They describe a population, and the statistic is calculated from a sample to estimate the parameter. Alright, so our parameter for proportions is P, and for means is mu. These are what represents the actual true proportion of the population and mean of the population. When we're dealing with statistics, they're actually calculated from a sample. Our statistic for proportions is p hat, and our statistics for means is x bar. Alright, the whole point of getting a statistic is to estimate a parameter, right? So how do we know if a statistic is a good estimate of a parameter? Meaning, like, this gives us a good idea of what this actually is. Well, if it has two things, low bias, or unbiased, right, and low variability. I know you've definitely heard that word variability before, meaning how spread out the data is, so we don't want it very spread out. And then low bias, we'll show you what that means today. Alright, so here are the two different things we're looking for. An unbiased estimator is the statistic that is an unbiased estimator if the center of the sampling distribution is equal to the true value of the parameter. So looking here, I've got three different statistics. I've got statistic A, statistic B, statistic C. So these are different sampling distributions, right? If the actual value of the population parameter is 4, which dot plot can be used as an unbiased estimator? So here's the number line at the bottom. If 4 is my true statistic, if 4 is my true parameter, the true population parameter, which one of these is unbiased? A, B, or C? Okay, you said A, because it shows the true mean or the true expected value, right, of the population, because we're saying the true parameter is 4. A is an unbiased estimator. Alright, low variability, the larger random samples tend to produce estimates that are closer to the true population value, meaning not spread out but closer. Which dot plot displays the highest variability? It's got high variability, it's pretty spread out. So what do you think has the highest variability? A, B, or C? I hope you said C, because C is definitely the most spread out. Alright, and that's pretty much it, you guys. So let's go through some examples together. Alright, so biased and unbiased estimators. So use the dartboards below to evaluate bias and variability. The bullseye is the true population parameter. So the center, the bullseye of the dartboard is the true population parameter, and the darts are estimators. Label the 4 targets using the following categories: high bias, high variability; low bias, high variability; high bias, low variability; and low bias, low variability. Remember, bias means how accurate it is, variability means how spread out it is. So I'll give you a second to look at these different darts with the options. We're going to go through and name each one. Alright, so let's start off with this one here. What do you think it is? Do you think it's A, B, C, or D? Alright, I hope you said C. This one is C because it has high bias. It's away from the center of the bullseye, but low variability because they're pretty packed close in together. Alright, what do you think about this one? Alright, for this one I hope you said B. So the darts are clustering around the center of the bullseye, which means it has low bias, but they're pretty spread out. So low bias, high variability. So we've got C and we've got B. Alright, let's go ahead and look at this one. For that one, I hope you said A. High bias and high variability. It's away from the bullseye, so it's not a good estimator. It's not very accurate, so that's high bias. And then there's pretty spread out, so that's high variability. What about this last one? I know there's only one option left, but you can see the dots are in the center of the bullseye and they're all close together, which would be D, which is low bias, low variability, which is what we want to estimate a population. Low bias, low variability. All right, let's do a few quick Khan Academies together. You don't have a Khan Academy assignment for this but I wanted to go through a few together with you just to make sure that you had a good understanding. But again, you don't have a Khan Academy for this. We're just doing it together, and you're answering in the Ed puzzle. All right, the dot plots below show an approximation for the sampling distribution for 3 different estimators, A, B, and C. If the actual population parameter is 4, which dot plot displays the estimator with high bias and low variability? So it's 4. We want high bias, which is not very accurate, but low variability. Take a look, see which one you think it is. All right, I hope you said statistic B. If you see how they're pretty close together, that indicates low variability, but it's not centered around 4, so it's not very accurate. Okay, Alejandro was curious if the sample median was an unbiased estimator of the population median. He placed ping pong balls numbered 0 to 32 in a drum and mixed them well. Note that the median of the population is 16. He then took a random sample of 5 ping pong balls and calculated the median of the sample. He replaced the balls and repeated this process for a total of 50 trials. His results are summarized in the dot plot below, where each dot represents the sample median from a sample of 5 ping pong balls. Based on the results, does the sample median appear to be a biased or unbiased estimator of the population? We need to know what the population median is, what the parameter is, and it's 16, so it's right here. So what do you think? I'll go ahead and scroll down to the actual answer choices. I'll give you a second to read these. I hope you said C, because it's actually right in the middle. So it's relatively accurate, but it's just got a high variability. So C, because we're not talking about high or low variability in the answer choices. We're talking about biased or unbiased. All right, and the last one. All right, I'm going to skip down to the question. Based on the results, does the sample IQR appear to be a biased or unbiased estimator of IQR? So the population IQR is 16, which is right here. So take a second to read through the answer choices. All right, I hope you said A. We're saying A here because the results of the sample IQRs are not very accurate. The true IQR is at 16, and most of these samples are below. So that means that these samples underestimate because they're typically below what the actual IQR is. So it's consistently underestimated. All right, let me go ahead and go back to the document camera so I can show you guys some College Board questions. All right, so we have 2 practice problems with these, and then we are done. Okay, so a certain statistic D hat is being used to estimate a population parameter D. The expected value of D hat is not equal to D. What property does D hat exhibit? So we're saying that D hat does not equal D, when the D is the parameter. So take a minute and look through these answer choices and see what you think. All right, I hope you said E. D hat is biased. Remember, our statistic is biased if it's not equal to the actual parameter, right? If it's not accurate, that creates a biased statistic. We want one with low bias because we want it to be relatively accurate. All right, which of the following conditions would create a biased estimator of a population parameter? A biased estimator of a population parameter. Go ahead, read through the answer choices and let me know what you get. All right, for this one, I hope you said D. This was a little difficult, but let me go through these answer choices. A, B, and C are all talking about the sampling distribution of the estimator, right? We don't really care about the sampling distribution of the estimator. We care about the accuracy of the estimator. We want to know if the estimator is equal to the population parameter. So just because the sampling distribution is skewed to the right or the left, that doesn't necessarily mean that our estimator is inaccurate. It can still be equal to the population parameter. So this doesn't explicitly tell us that our estimator is off. All right, this says the expected value, which would be the mean, the X bar of the estimator, is not equal to the population parameter mu. This is exactly the definition of a biased estimator.